So we have about 14 minutes left, so I think we can open up the Q&A. If you are going to ask a question, it would be great if you could use the microphone over there. I could also pass it around, but the audio is being recorded, so it'd be much appreciated if you could speak into the microphone. Does anybody want to start us off? Jay?
Thanks for a great, I'm not sure this is on. It's on. Thank you for a great series of panel presentations. Question for Eli. Could you talk about the response of the in-basin interest groups to your study, kind of coming away from that? And then just also, Jeff, in terms of especially looking at the wetlands water budgets for each of the refuges, can you talk, is there any additional study that's kind of going into that in terms of kind of analyzing both consumptive use as well as just the water plans and needs for the refuges? Thank you.
I would say the response of the in-basin people has been pretty, I guess, positive from the tribes and the environmental groups. From the agricultural community, pretty skeptical, I would say. And really, I think what they would need to really buy into this is local validated data. Both, in terms of the ET measurements, but so I think things are changing a little bit, and now that this data is out there, I think there's a realization that we do need to have some metering, we need to have some more local field studies to validate this. And the thing about the overestimation of wheat, that came from a farmer who saw one of my presentations, and he's look, I'm applying 38 inches to my alfalfa fields and 15 inches to my wheat field. It was the same field, but it's just the crop rotation, and he's saying there's very little difference in the ET data. So that was where that came from. Yeah.
Okay, great. Good question, Jay. And I think I don't have a super fulfilling answer, unfortunately, on the wetland side. Basically, I think the punchline is that wetland ET is extremely heterogeneous over space and time, and you better think about things a bit more carefully when you're trying to characterize that, especially in the context of Sigma and doing your water budgets and all that. I think people have heard that, but there's no clear action items lined up for next steps. And I've been trying to get maybe TNC and Audubon and Point Blue and EDF perhaps together to have that conversation basically and think about what should we do moving forward when it comes to characterizing wetlands and that sort of thing. So, yep.
So we are all believers here in Open ET, and the one presentation that is lacking is why I don't want to use Open ET. And I think that's an important question, also referring what you just said. During the last 2 years, twice in California, I met a lot of resistance against using a remote sensing technique. And really by professionals that think, how can you come and end up with this position? So my question to the panel is this common or did I just have bad luck? And if this is really the case, what would be the best way to introduce OpenET to people that can benefit a lot with it?
Skeptics, definitely. I think probably some of it's tied to the way you make decisions and being familiar with. I think you want to use a method that you're familiar, and changing satellite data and processing GIS skills really requires just bringing in satellite-based information in your workflow. I think that could be one of the reasons. And also, accuracy tends to vary. Sometimes in your backyard, it may not be working at all. So you may lose confidence because of that. Because there's just a lot of information, and there's a lot of chance for people to say it does not work here, it does not work here, and that kind of gangs up, that builds up a little bit, especially, gives fodder for the skeptics. I think what we need to do is just show what it means, accuracy, it's at regional scale, and how it can be used for water budget at what scale. So I don't think you should really judge by how the pixel or one wheat field is working. We have to look at how this works at a larger scale, but maybe just.
Yeah, those are great thoughts, Gabriel. And I think maybe just to layer in maybe two additional thoughts to that. So one is this sense of, what alternatives do we have, right? I mean, there's a lot of resistance that you'll come up against with remote sensing for consumptive use estimates, but if you really drill into it, if it's coming from a grower, for example, you can have a conversation and be like, well, if I were to walk through your field with you, would you say that every part of your field is the same? Oh, no, I got a soil problem over here. I got, salinity issues there. I have water logs over here. Okay, so that's what the satellites can help us see, because the alternative is to pull a crop coefficient that was developed in Kimberly, Idaho from a textbook and then multiply it by the reference ET. And that's good, but I think this is a step towards, better, even though it's not perfect. So that's one thought. And the other thought is to build on people's intuition about how this process works. And a lot of times I just use like the sweating analogy and build that intuition that when you have evaporation happening, it cools things down because it takes a lot of energy. And so by looking at these thermal images of the land surface, we can get a sense of the changes across the landscape and evaporation. So building on people's intuitions oftentimes is helpful depending on what their background is and kind of where they're coming from.
I think one more thing I would say is that more sort of crosswalking of different sources of information. So presenting the satellite-based estimates in context with, the like crop coefficient-based type approaches, doing things at the scale of individual fields, like an on-the-ground photo of like, well, here's what this field looked like at different times of year. Here's what it looked like from the sky. Here's the thermal imagery. Here's the greenness indices. I do think that, to me, the thermal image that I showed is really powerful because the end product of the ET has so many different steps and things to it, but the thermal imagery is really more of a raw type visual that, to me, is more effective because it's not so many steps of complexity.
I have used photos in this way, but without success.
Some people just have a hard time understanding things they don't want to understand. So that's
So just to point out, I was at a conference recently, A.G. Chapman, and there someone asked, so if you had tons of money, what will you do with it? Like, will you spend it on having more sensors, remote sensing sensors, or build in situ systems? So the answer is we need both. And in my area of study, I showed that with remote sensing, we can pick out metadata that have too many errors in them. So for example, we see these fields where the NDVI is high, more than 0.5, but the pumping meter, it has 0 feet of water applied. And so we can see these discrepancies with remote sensing. And that's why I think we need both sort of in situ as well as remote sensing estimates.
Great. Just on that same theme, I'm curious if you looked at other verification methods. So Eli, in particular in the Scott Valley, the farmer who said, I applied 15 inches here and 30 inches for this time, how did they make that estimate? And have you looked into things like, how do they do the pumping? Is it electricity, PG&E records? It would be interesting if we could think of other approaches to establish a baseline and then compare years from.
Yeah, certainly the idea of using electric meters has been discussed, and I think it would be great to throw into this mix of a place where there's meter data, there's remote sensing data, there's electric meters. I guess there's some complications with the meter data because like in a drought year where the water surface elevation is deeper, it takes more energy to pump up than in a high water year. In the Scott, the water table fluctuates a lot from year to year. So there's kind of some stuff to untangle. Or let's say you upgraded your equipment to a higher efficiency, lower energy pivot with a variable frequency drive. That's going to change your sort of ratio of electricity to water. So I think the meters probably work well if or the electric meters could be work well if there wasn't major changes in infrastructure. But once you change the infrastructure, then you need a new relationship.
Yeah, and I think this kind of just adds on to maybe both of what you just said in terms of I think having to be like MacGyvers out there to get at these things. Like we have to take all these points of information and try to kind of triangulate between them all. And so whether it's power records or flow meter records or any other sort of anecdotal evidence from the growers and their sense of how much water they're applying, I think we need to take all those into account when we try to make sense of what's actually happening and kind of try to triangulate between all these points of data.
And also just one quick thing on the electric meters. The farmer who was telling me about his wheat field, he said, I went to the website of my electricity provider and they only provide 2 years backwards of the power bills. So he knows, what dollar value check he wrote, but he doesn't have access to the kilowatt hours anymore.
Yeah, thank you for the presentations. My question is to Jeff. So you presented groundwater pumping estimation using consumptive ET. So my question is how do you account for groundwater pumping in more complex systems? Like if there is surface water irrigation and you don't know anything about surface water data or something. Yeah.
Okay, yeah, great question. So this methodology is quite straightforward in areas that are groundwater only, groundwater dependent areas with no surface water. As you introduce more surface water into an area, the results become more uncertain, and that it really has to do with how the level of precision you have, the spatial understanding of your applied surface water. So the worse understanding the worse your understanding becomes, the more uncertainty there is in your groundwater pumping estimates, at least from a spatial distribution perspective. So what we're doing in our context is at least, in California, every single diverter has to report their monthly diversions to the State Water Resources Control Board. So at the very coarsest scale, we at least have monthly data spread out over their place of use. And then basically we can look at land use and spread those molecules of water evenly across irrigated portions of that landscape. But of course, do we really think that the water was spread out evenly across the landscape for the irrigated fields? No, we know that it's different. So the better thing is to have field scale applied water data, and those data sets are hard to come by, and they're also full of problems, and meters are difficult to develop robust data sets. But yeah, it's really important in these mixed areas to have good applied surface water data to be able to back into applied groundwater data.
With that, it looks like we're just about out of time. So thank you, everybody, so much for attending, and big thank you to our panelists for such a wonderful discussion, amazing insights.
Yeah.
Oh, cool. Okay, I left my phone on the podium.
Oh, keep asking. So is there do you guys have any plans to take the CBOP backwards in time, back to 84 for the whole nation? What's the status of that?
We are working on data release, but yeah,
For the whole country, not just for that area of the nation? Oh, wow. When is that? Like months?
Yeah, months.
Okay.
We found out a lot of missing data in the early years, but
Yeah.
still, some good data here.
Yeah.
We'll make it available this year.
Great.
Yeah.
And will that be monthly or annual? Oh, wow. Awesome.
Yeah, we're gonna clean up those ones that